Feature engineering is the process of using domain knowledge to create new input features from the raw data that help machine learning models perform better. It involves transforming raw data into features that better represent the underlying problem to the predictive models, resulting in improved model accuracy and performance. Importance of feature engineering. First, it improves model performance. Well-engineered features can significantly boost the performance of machine learning models. Second, it simplifies model complexity. By creating informative and relevant features, the complexity of the model can be reduced, making it easier to interpret and understand. Third, it enhances model robustness. Good features can make models more robust and generalizable to new unseen data. Finally, it reduces overfitting. Proper feature engineering can help in reducing overfitting by capturing the underlying patterns more effectively. Steps in feature engineering. First, understanding the data. Explore the data set to understand its structure, types of features, distributions, and relationships between features. Second, handling missing values. Deal with missing data through methods like imputation, deletion, or using algorithms that support missing values natively. Third, encoding categorical variables. Convert categorical variables into numerical form using techniques like one-hot encoding, label encoding, target encoding, or ordinal encoding. Fourth, scaling and normalizing. Standardize or normalize numerical features to ensure they have a similar scale, which is important for algorithms sensitive to feature scaling, like gradient descent-based methods. Fifth, creating interaction features. Generate new features by combining existing ones, such as polynomial features or interaction terms, to capture relationships between variables. Sixth, feature transformation. Apply mathematical transformations like log, square root, or power to features to make them more suitable for modeling. Seventh, feature selection. Identify and select the most relevant features using techniques like correlation analysis, mutual information, recursive feature elimination, or model-based selection methods. Lastly, dimensionality reduction. Reduce the number of features while preserving the most important information using methods like principal component analysis or PCA or TSNE. Techniques in feature engineering. First, let's talk about normalization and standardization. Normalization rescale features to a fixed range, typically 0 to 1, using min-max scaling. Standardization, on the other hand, rescale features to have a mean of 0 and a standard deviation of 1. Next, we have polynomial features. This involves generating polynomial terms like squares and cubes of existing features to capture nonlinear relationships. Log transformation is another important technique. By applying the logarithm function to skewed features, we can reduce skewness and make the distribution more normal. Binning is also quite useful. This technique discretizes continuous variables into bins or intervals, which can help capture non-linear relationships and reduce model complexity. When it comes to encoding categorical variables, there are several methods. One-hot encoding creates binary columns for each category of a categorical feature. Label encoding assigns a unique integer to each category. Target encoding replaces categories with their corresponding target mean. Feature interactions are another powerful tool. By creating new features through multiplying or otherwise combining existing features, we can capture interaction effects. For time series data, we can create time-based features. This includes features like day of the week, month, quarter, or lagged variables to capture temporal patterns. Lastly, for textual data, we can use text features. Techniques like TF-IDF, word embeddings, or n-grams transform text into numerical features. Example of feature engineering. Let's consider a data set of housing prices. The raw data includes features like the size of the house in square feet, the number of bedrooms, the age of the house in years, and the neighborhood of the house. Now let's go through the feature engineering steps. First, handling missing values. We fill missing with the median number of bedrooms. Next, encoding categorical variables. We one-hot encode to create binary features for each neighborhood. Then, scaling. We normalize into a range of 0 to 1. Creating interaction features is another step. We create a new feature by dividing by. Log transformation is also applied. We apply log transformation to reduce skewness. Finally, binning. We bin into categories like and, the engineered features include yet, and so on also, and. Conclusion. Feature engineering is a critical step in the machine learning pipeline that involves transforming raw data into meaningful features to improve model performance. By applying domain knowledge and various techniques, data scientists can create features that capture the underlying patterns in the data more effectively, leading to more accurate and robust models. For more explanations of AI terminology, hop over to Ai-Epicentre.com. See you there.